Dear students, today we are going to learn about force. बल भन्ने कक्षा 10 को विज्ञान को पाठ को बारे में आज हामी पढ्न गइरहेका छौं। म हरिप्रसाद पोखरेल विज्ञान गणित को शिक्षक हो। आज तपाईहरुलाई यो फोर्स भन्ने च्याप्टर मा ग्रेभिटेसन को बारे में मैले बताउन गइरहेको छु। ध्यान दिनु होला। What is force? Force भन्नाले हामीले केलाई बुझ्छौं? तपाईहरुले force is an external factor which changes or tries to change the state of body भनेर state of rest or motion of a body भनेर पहिले पढ्नु भएको छ। यसको मिनिङ के भयो भने फोर्सले कुनै पनि अब्जेक्ट को स्टेटलाई चेन्ज गर्न सक्छ, त्यसको शेपलाई साइजलाई चेन्ज गर्न सक्छ, त्यसको मोसनको डाइरेक्सन चेन्ज गर्न सक्छ। डियर स्टुडेन्ट्स, हामीले एउटा ढुङ्गालाई तलबाट माथि फाल्यौं भने त्यो केही समयमा फेरि तल खस्छ। यो किन यसो हुन्छ? यसै विषयमा आज हाम्रो विषय केन्द्रित छ। लगभग 16औं शताब्दी भन्दा अगाडि बिफोर 16th century people thought that our earth is the center of whole universe. All the satellites, planets revolve around this earth including the sun. This theory was called geocentric theory. पृथ्वीलाई नै त्यस बेलामा विश्वको ब्रह्माण्डको केन्द्र मानिन्थ्यो। सबै ग्रहहरू, ताराहरू, सूर्य लगायतले पृथ्वीलाई परिक्रमा गर्छन्, रिभल्भ गर्छन् भन्ने मानिन्थ्यो। त्यो जियोसेन्ट्रिक थ्योरी 16औं शताब्दी पछि परिवर्तन भयो र मान्छेले सूर्य ब्रह्माण्डको केन्द्रमा छ भन्ने कुरा बुझे र सपोज गरियो द सन इज द सेन्टर अफ द युनिभर्स. All the planets and stars revolve around the sun. That theory is called heliocentric theory. Geocentric, okay. You learnt about these two theories. And why all the stars, satellites and planets remain in their own position? This was a large question before 16th century. What makes them revolve around sun or galactic center? This question was first time addressed by Sir Isaac Newton in 1687. Newton found that there is a force of attraction between any two bodies in this universe. Every object in this universe attract another by a force, and that force was named by gravitational force. Now we are in our main topics, gravitational force. Every object in this universe, either celestial or terrestrial, will attract each other with a force, and that force is called gravitational force. Newton gave a law that is called Newton's law of gravitation about the gravitational force. According to this force, every object celestial or terrestrial attracts another object by a force called gravitational force. This gravitational force is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Now today we focus to understand this Newton's law of gravitation. It is also called Newton's universal law of gravitation because it holds true for all the objects regardless those are celestial or terrestrial. आकाशीय पिण्डहरू ब्रह्माण्डमा भएका अथवा हाम्रो धरतीमा भएका जुनसुकै साना ठुला heavenly bodies or minute particles show this force of gravitation due to their mass. That's why it is also called Newton's universal law of gravitation. Dear students, we have to understand some terminology here. What does this directly proportional and inversely proportional mean? We will discuss it later. Let's first suppose there are two objects, one having mass m1 and another having mass m2. Their center of gravity, that is the point at which we can assume the whole mass of this object is concentrated, and this is the center of gravity of second object, and the distance between their centers is here represented by d. According to this law of gravitation, the force of gravitation between these two bodies A and B having masses m1 and m2 separated by distance d is, that force is directly proportional to the product of their masses. And that force is, according to the second point, that force is inversely proportional to their square of their distance. These two statements are mathematical representation of these 2 points of this Newton's law of gravitation. Now I will discuss what does this directly or indirectly proportional mean. Okay, to understand this, let's suppose number of pens, it is a example only, this example number of pens and cost, it is number, it is in rupees. I purchase 2 pens, it will cost rupees 20, 3 pens cost 30, 5 pen cost 50. What type of relation is this? If number of pens increases, then the cost is also increased. The way by which the first variable varies, it directly affected the variation of second variable. The number of pens increases, then the cost is also increases. Number of pen धेरै भयो, मूल्य पनि धेरै. Number of pen थोरै भयो, मूल्य पनि थोरै. जसरी यो number of pens को संख्यामा फरक परेको छ, डाइरेक्टली यसलाई असर गरेको छ. यस्तो रिलेसनलाई डाइरेक्टली प्रोपोर्सनल अथवा समानुपातिक भनिन्छ. डाइरेक्टली प्रोपोर्सनल. अब यसलाई हामीले के भन्न सक्छौं भने नम्बर अफ पेन्स इज डाइरेक्टली प्रोपोर्सनल टु कस्ट. यो इक्वालिटी होइन, यसले भेरिएबल कसरी भेराइ भइराछ भन्ने कुरा मात्रै बताउँछ. यसले कसरी भेरिएबलहरु भेराइ भएको छ भन्ने बताउँछ. यहाँनिर हामीले 2 इक्वल टु 20 त भन्न सक्दैनौं. यसलाई हामीले 2 इज डाइरेक्टली प्रोपोर्सनल टु 20 भन्न सकिने भयो. बरु के गर्न सकिन्छ भने नम्बर अफ पेन्स इक्वल टु 1/10 अफ कस्ट गरिम भने अब हेर्नुस् त हाम्रो यो पहिलेको स्टेटमेन्ट जुन प्रोपोर्सनालिटीमा थियो अब इक्वल भयो. नम्बर अफ पेन हेर्नुस् है, 2 वटा पेन भयो. 2 इक्वल टु 1/10 अफ कस्ट कति थियो 20. 10 1 जा 10 2 जा, यो भ्यालिड भयो नि हैन. यसरी हामीले यो स्टेटमेन्टलाई इक्वेसन बनाउनको लागि एउटा नम्बर राख्नु पर्दो रहेछ. 1/10 अथवा 0.1 वी क्यान से एउटै कुरा हो. फ्र्याक्सनमा 1/10, डेसिमलमा 0.1. यो भनेको यहाँनिरको प्रोपोर्सनालिटी कन्स्टेन्ट भयो. अब के बुझ्नु पर्यो भने प्रोपोर्सनालिटीलाई इक्वेसन बनाउनको लागि कुनै एउटा कन्स्टेन्टले मल्टिप्लाई गर्नु पर्दो रहेछ. अब हामीले यो दुईटा प्रोपोर्सनालिटी रिलेसनलाई कम्बाइन गर्यौं भने कम्बाइनिङ 1 and 2 फर्स्ट एंड सेकेंड रिलेशन, f is proportional to m1 m2 upon d square. ल f proportional to m1 m2 d square भयो. यसैलाई हामीले यदि इक्वेसन बनाउने हो भने f इक्वल टु केही कन्स्टेन्ट राख्नु पर्यो अनि m1 m2 अपन d स्क्वायर. ख्याल गर्नु होला, जसरी हामीले अघि नम्बर अफ पेन्स र कस्ट को रिलेसनलाई इक्वेसन बनाउन एउटा प्रोपोर्सनालिटी कन्स्टेन्ट दिनु परेको थियो. सिमिलरली यो एउटा प्रोपोर्सनालिटी कन्स्टेन्ट हो वेयर g इज अ प्रोपोर्सनालिटी कन्स्टेन्ट known as universal gravitational constant. Okay, here g is a proportionality constant and it is universal gravitational constant. It is also called universal constant. This law was universal law of gravitation and this constant is also universal gravitational constant. Universal means it is independent of time and any other circumstances. That is, the value of g is constant for every minute particle. एकदमै सानो वस्तुको लागि, दुईटा सानो वस्तु बीचको एट्र्याक्सन फोर्समा पनि यही कन्स्टेन्टले काम गर्छ र दुईटा ठुलठुला हेभेनली बडीज सेलेसियल बडीजकोमा पनि यही जी ले काम गर्छ. इट होल्ड्स ट्रू फर all celestial and terrestrial minute or heavenly bodies. So it is called universal gravitational constant. Okay, this is therefore f equal to g m1 m2 upon d square. It is the mathematical representation of Newton's universal law of gravitation. By observing this equation, we can say that this g is merely a constant. It is a constant. It does not depend on any other variables. If it is so, then on what factors does this force depend? We can summarize the law of gravitation in this equation. The force is directly proportional to the product of these masses, that is m1 and m2, mass of first and second body, and it is divided by d square. It means the force is inversely proportional to the square of the distance between their centers. These two are the factors on which this gravitational force depend. What are the factors on which gravitational force between two bodies depend भन्यो भने, now you can answer. Those two factors are the product of their masses and square of the distance between their centers. Okay. Now we have to learn about this g. Okay, here this g is universal gravitational constant. Scientists found its value empirically, that means practically they found its value, and its numerical value of g is 6.67 into 10 power minus 11 Newton meter square per kg square. Okay, what does this g numerically mean? यो g भन्ने संख्या एउटा यो अचर संख्या हो, कन्स्टेन्ट संख्या हो, यसले एक्चुअली केलाई न्युमेरिकल्ली रिप्रेजेन्ट गर्छ त भन्दा हामीले यही रिलेसनमा हेरौं. इफ two objects of unit mass means 1 kg mass, are separated by 1 meter distance, then F equal to g. Both masses are unit masses, that's why 1 into 1 upon they are separated by 1 meter distance, means those are 1 meter far from each other, 1 square, it gives F equal to g. Here the force, gravitational force becomes equal to gravitational constant, that is numerically g is equal to the force of gravitation between two unit masses placed at 1 meter distance अथवा unit distance. In this way, students, the numerical meaning of g is the force of gravitation between two unit masses separated by 1 meter. That is, we can say that if two masses of 1 kg each are separated by 1 meter, then the force between them is also equal to the numerical value of G, that is 6.67 into 10 power minus 11 Newton. Here we have to understand that F and G are here numerically equal, but these two quantities are different. That's why their unit are different. It is force, that's why we write Newton. If it was G, then we will write Newton meter square per kg square. Okay. Thank you, students. Today we discussed about what is gravitation and what is Newton's law of gravitation, and how can we derive the Newton's law of gravitation, why it is called universal law, what is the value of G, and how we find the numerical value of G. Also its unit. Okay, for unit of G we can use the same statement, F equal to unit of G. For this F equal to G m1 m2 upon d square. F is measured in Newton and G m1 m2 both in kg. Kg into kg, it is kg square, and d square means meter square. Distance is measured in meter, that's why d square means meter square. In this way, if we put here G and all other these units in another side, we will get G equal to Newton meter square per kg square. This is the unit of G. Thank you, students. Today I will end the class. Your kind suggestions will help us to improve. Thank you.